Have you ever come across this kind of string on top of Python functions and ask yourself, what the hell is that? Those are Python decorators. And in this video, you're going to learn everything you need to know about Python decorators and how to use them to improve your Python code. But before that, if you're new here, my name is Cons and I make videos on programming, computer science, and everything in between. And if that sounds like your cup of tea, make sure to subscribe to my channel and check out my other video after this one, where I talk about the Python unpacking operator and how to use it to improve your Python code. Before we can take a deep dive into Python decorators, we have to talk about the first-class nature of Python functions. Every Python function is treated as an object and therefore has the same properties as any other object in Python. So let's have a look at this example over here. We have an add function that returns just the sum of two numbers. And any object in Python has a type. So with the first class property of a function, also a function has a type. And the function of a type is function. We can also assign a variable with a function. So we have the variable var and it assigns to add. And then we can call var with the matching arguments of the function we have assigned, 1 and 2. And this will return free because in the background it calls the function add. Another property is that we can pass a function as an argument to another function. So let's define a wrapper function, which gets a function as a parameter. And inside we are going to return the value from the function we have passed with the appropriate arguments and return the return value from wrapper. If we now call wrapper with the add function as an argument, we can see it returns free because add was assigned to f inside the wrapper function, and inside the wrapper function, the return value of f was returned from the wrapper. We can also return a function from another function. So for that, redefine our wrapper function, wrapper this time without any arguments. And inside the wrapper function, we're going to define another function, and we're going to use the add function because we're already familiar with it. Return x plus y, and then we are going to return add from that function. So if we now call the wrapper function wrapper and assign its return value to var, and we call var 1, 2, it will return free because var is now assigned to the add function we have returned from our wrapper function. Because Python functions are objects, they also have a hash value. So if we enter hash add, we can see it returns the hash value of the add function. And last but not least, we can also store functions in container data types such as lists, tuples, or sets. So we enter L equals bracket add wrapper. And if we now call type L, we can see it is a list. And inside that list are functions, because we can now call L0 bracket and then 1, 2. We can see that returns our value free because the first value of our list is the add function we defined up here. With the knowledge of the first class nature of Python functions and that every Python function is actually an object, we can do some pretty cool things. So let's have a look at this example over here. We have the add function, which just adds two numbers together as we have seen before. And up here we have the successor function, which gets a function as a parameter. And inside the successor function, we have the wrapper function, which will then be returned. The wrapper function has an arbitrary amount of unnamed parameters and an arbitrary amount of keyword parameters. And if you don't know what that means, check out this video up here. Those unnamed parameters and named parameters are then passed to the function which comes from the parameter list of the successor function. And we pass the arguments and keyword arguments into that function, get the result of function, and add +1 to the result and return that. And in the end, we return the wrapper function. So what does this actually do? When we call the successor function and pass the add function, we can create a new function because we get returned the wrapper function, which encloses the function we have just passed to the successor function. This will create a new function, which is called add +1, because to the result of our add function, we are now adding +1 as we've seen up here. So if we run that code, we can see when we add 23 plus 42, we should get 65, but we add +1, we get 66. However, it is rather tedious to pass a function to a function, then assign that to a variable, and then call the new function. And therefore, the Python decorators exist. Instead of calling the functions down here, we're going to use the successor function as a decorator on top of the add function. So we add suc on top of the add function, and when we now call the add function with 23 and 42 and run that code, we get 66 as well. Because the decorator does the same thing as the code down here. It wraps around the add function, returns the wrapper, which then adds +1 to the function we have decorated. And this is a nice little shortcut to wrap a function around another function to change its behavior using Python decorators. And by the way, if you're new to Python or already a seasoned developer and would like to pick up some cool cheat sheets about Python data structures or Python file I/O, check out my Gumroad shop with the link down below in the description, where you can pick up free cheat sheets as a PNG or as a printable PDF for just €5 a piece. Simple decorators, as the one we have just seen, always follow the same structure. We have a function which gets a function as a parameter and gives the decorator its name. Inside that function is a wrapper function which gets args and keyword args, and inside that wrapper function, the function that is decorated is encapsulated and gets the args and keyword args. And then we can use the result of that function and modify it and return that wrapper function from the decorator function. However, decorators don't have to be static. In this example, we added 1 to the function we decorated. But maybe we would like to add another number, maybe 3, 23, 42, any other number. And it is actually possible to pass arguments to a decorator. To do that, we have to change the decorator code. Instead of returning the wrapper function inside the successor function, we're going to create a new function inside the successor function called decorator, def decorator, which takes function as an argument, and the successor function doesn't take the function as an argument. The successor function gets the parameters that we would like to have in our decorator. So we changed the code over here and add number. That is the number we would like to add to our wrapper function down here. And then we're going to enclose the wrapper function inside the decorator. And instead of returning the wrapper function from the successor function, we are going to return the decorator, which returns the wrapper function. So return decorator. And if we now change the decorator successor to number equals 3 and run that code, we can see it returns 68 instead of 66, because now we are going to add 23 and 42, which is 65, and then we add the number we have passed to the decorator to the result of that function, which results in 68. So passing an argument to a decorator is a little bit more convoluted than a normal decorator, because we have to nest 3 functions into each other. First, a function that gives the decorator its name and the arguments, then a decorator function which takes the function we decorate as a parameter, and then a wrapper function which implements the logic of the decorator. And then we are going to return the wrapper from the decorator, and from our function over here, we're going to return the decorator. Because Python functions are first-class objects, we can not only pass simple arguments to a decorator, we can also pass functions to a decorator. And for that, we're going to add f over here, which has as a default value the successor function itself. And then we're going to enclose the function we decorate with f. And down here, I defined a new function mul2, which just multiplies the value by 2. And now we can decorate our add function with number equals 3 and f equals mul2. And if we run that now, we can see the result is 133, because now we have passed the mul2 function as an argument to our decorator, which then wraps around our function in the wrapper function. But now our code looks pretty convoluted. So instead of passing a function as an argument to a decorator, let's turn our function into a decorator itself and then nest all the decorators we have defined. So instead of just multiplying by 2, we're going to turn mul2 into a decorator, give it the parameter function. Inside, we're going to declare a wrapper function with args and keyword args, and we're going to return the function we want to decorate and multiply it by 2, and then return the wrapper from our mul2 function. Up here, we're going to remove the parameter function and keep it as we have it before with just number as an argument. And down here, we also have to remove that argument from the decorator. And now we can decorate our decorated function. If we run that, we can see we get a different result now. Instead of 133, as we have seen before, we get 136. And that is because we first apply the successor function and then the mul2 function. If we change the order here, we will get the result we had before, 133, because the decorator that is closest to the function we decorate is applied first, and then the decorator on top is applied to the already decorated function. So with this, we can nest decorators and make our Python code even more versatile. Up until now, we have only used functions to decorate other functions. However, Python is mostly used as an object-oriented programming language. And therefore, we're going to have a look at how to use a class as a decorator. Let's take a look at this code over here. We have the count class, which has a constructor which gets a function passed as an argument and also has a count. Then we have another dunder function called call, which takes arguments and keyword arguments and increases the count, then prints the name of the function we have defined over here and the count we have defined up here. And in the end, it will return the result of the function we have passed to the constructor. We have the function add and mul, and we can now use the class count as a decorator to count how often add and mul have been called. So if we run this code right now, nothing happens. We just call add and mul down here. But if we use count as a decorator for add and mul and run this code again, we can see that it now prints out that add was called and also tells us how often add was called. So the first call is add is here. Current call count of add is 1. Then we have a second call is 2. And now for the mul function, we don't get free because every time we apply a class decorator to a function, a new object of the decorator class is instantiated. So add and mul have their separate instances of the count class that tracks the call count of those functions. We can see here mul is 1, and then we call add again, which is 3, and then mul once again, which is 2, which matches exactly what we have done here. First add, second add, then first mul, third add, and then second add. Such a class decorator as the count decorator we have just defined here can help you to figure out bugs of your code and maybe track how often a function is called if that is not super obvious due to the structure of your code. And you might ask yourself, can I also pass an argument to a decorator class? And yes, that is possible, so let's do that. So instead of always printing the same message for each function we decorate, we would like to customize that message. So therefore, we have to pass a string to that decorator. So let's change the decorator. Instead of passing a function to the constructor, we're going to pass a message and store that message in an attribute. Then we have to modify the call function, which now doesn't take arg and keyword args, it takes the function we would like to decorate. Inside the call function, we're going to define a wrapper function, which takes the args and keyword args, and we're going to return that wrapper function. And if you have already figured out, we're going to implement the logic that will be imposed onto the function we decorate inside that wrapper function. So we move the code from down here inside the wrapper function, and we change this call over here just a little bit with the message we have passed. So we enter self message, and we also have to store the function we have passed to our decorator with self func, so we can also access it in here. Now we have to change the decorator call over here. We enter here hello, and down here hi. And if we run that, we can see that now the hello is applied to the add function and the hi is applied to the mul function, while we still have the counting feature inside here, which we haven't printed yet, but we have the count over here and we could print it if we would like to. So a decorator class has in its essence the same shape as a normal decorator, but we are going to use the dunder call method in order to implement that decorator. And if we would like to pass an argument to our decorator class, we have to use it in the same way as we have done with function decorators. We have to return a wrapper which implements the logic and takes the arguments and the function we would like to decorate. Now we have seen how to decorate functions with functions, how to decorate functions with classes, and now we're going to decorate classes with other classes. For this use case, I also prepared a little example. We have the class foo, which has one attribute called bar, which we pass to the constructor. Down here, we are going to create instances of foo with 42 and 23, and then we can access the attribute bar with the point operator in this print function down here. And if we run that, we can see we get 42 and 23. Now we would like to track how many instances we have created of that foo class. For that, I created a function called countInstances, which gets a class as a parameter. And inside the function countInstances, I have a class called countInstances, which inherits from the class I have passed to the countInstances function. We declare a class attribute called count and also a constructor which takes the arguments and keyword arguments, calls the superconstructor of the class we have inherited from with the args and keyword args, and then increases the class attribute count every time this constructor is called. And the countInstances function then returns this class. So we can now use the countInstances function and decorate our foo class. And with this decorator, we can now count the instances of the foo class. So in order to check that out, we are going to add two prints here, foo count, every time we create a new instance of foo. And if we run that, we can see it counts to 1 and then to 2 for each instance we have just created. You might ask, which type does foo have now? So let's have a look at that. Let's print type of foo0 and check that out over here. We can see the type of foo0 is not foo. The type is actually main countInstances locals countInstances. But this shouldn't bother us, because if we check if foo0 is still an instance of foo and we run that over here, we can see that foo0 is still an instance of foo, because foo is now of type countInstances, but countInstances inherits from foo. Foo0 is also an instance of foo, which is done through the magic of inheritance. Last but not least, you might ask yourself, can we also pass arguments to a class decorator? And yes, this is possible as well. So let's have a look at it. In our countInstances decorator, we would like to pass a message to our countInstances decorator. So instead of using the class as a parameter, we're going to use message with a default message hello. Inside the countInstances function, we're going to declare the function decorator, which takes the class we have passed before as a parameter, and the decorator function will have the decorator class inside of it, and from the countInstances function we're going to return the decorator function. The message we have declared as a parameter for our decorator we can use in the constructor of our countInstances class by using self-message, and then we assign self-message the message, and we also going to declare a new method for our countInstances class, which is called print message def print message self, and then we're going to just print self message. Now we can use the message as an argument for our decorator. So instead of hello, we're going to pass hi, and then we can call the print message method for every instance of foo that has been decorated with the countInstances decorator class. So down here we're going to add foo0 print message, And we also do the same for foo1. And we can now run this code over here, and we can see we not only count the number of instances, but each instance now has the ability to print message. This is actually a very convoluted way of implementing inheritance for a class in Python, because the decorator does nothing else than passing the decorated class as a base class to count instances. And then the class that is returned when we call the constructor of foo is not of type foo, but of type count instances, and possesses the same abilities as the foo class we have created here, together with the print message we have added on top of it. In this video, you have learned how to use Python decorators and how to decorate functions with functions, decorate functions with classes, and how to decorate classes with classes, and even how to pass arguments to decorators. If you made it so far, make sure to comment with a computer emoji down below. Give this video a like, and if you would like to get in contact with like-minded people, check out our Discord community with the link down below in the description. I wish you a pleasant day and hope to see you soon.